So now three-dimensional problem. So there are three-dimensional available. As you see, you are sitting in a room. It has length, breadth, as well as height. Okay. So this is called as three-dimensional pictures or three-dimensional geometry. Or you can say, as we are solving mathematics questions, so it is three-dimensional problems. Okay. So like you see that cuboid. Cuboid means all the three sides are different, or two sides may be equal, but third will be different. Okay. And you can see that prism over there, cylinder over there. Cylinder has length, breadth, as well as height. Pyramid over there, cone over there, sphere over there. Okay. So these figures are three-dimensional figures. Okay.
Yes.
Okay. So these are said to be 3D figures. And in 2D, you have only two-dimensional. Like you have a paper of your notebook. So that is two-dimensional because it doesn't have a thickness. It is having minute thickness.
Yeah.
Okay. So any surface is a two-dimensional figure. Any surface.
Yeah.
Okay. Now, is it visible?
Yes, sir.
Okay. You have to visualize where is the right angle.
So what?
Where is the right angle in this figure? Figure 7.8 shows a plane with a few lines drawn on it. See, this is a plain paper. Okay, few lines are drawn over it. Okay. So as shown in figure 7.8, we use the set square to check the pencil is perpendicular to every line on the plane. You can use it set square so that you can check it whether it's a perpendicular line or not. See, these are not perpendicular. It is very well by seeing only we can say that this line is not perpendicular to this line as well as this line.
Yeah.
Okay, but it doesn't seem to perpendicular to this also, that OD. Okay. So we are neglecting this OB line. It is not perpendicular to any of the line. Now we can check it OA and OC. They are looking like they are perpendicular to each other, but they are not perpendicular to OD as well as OC is not perpendicular to OD. Okay,
Right.
but you can check it OA and OC whether they are perpendicular to each other or not. Just check it. You have book. Okay, you have D over there to check the angle. And you have to actually he is telling you have to use a set square.
Okay then.
So use the set square to check that pencil is perpendicular. Okay, no. He is telling place a pencil perpendicular to the plane. So you have to place a pencil over there at O. Okay. Keep it at O and make it perpendicular to the plane. Okay. Now, can you see, is it perpendicular to each and every line? It is perpendicular. It is perpendicular.
Yeah.
Because the plane is perpendicular to the pencil.
So it's perpendicular, yeah.
And all the lines are lying into the plane. So that's why the pencil will be perpendicular to each and every line. Okay, so it will be perpendicular to OA as well as OB as well as OC as well as OD. Okay, so that was the your pencil is called a normal to the plane. So it is called as normal to the plane because it is perpendicular to the plane. Okay, it is perpendicular to every line on the plane. So it is said to be the normal. Normal means the perpendicular. Okay. So if you trace any of the line which is into that plane, so all lines will be perpendicular to that pencil. Okay. So that pencil is said to be the normal to the plane. Okay. Now got it? Okay. Now in figure 7.8c, now we'll talk about 7.8c. On ON, so ON is your pencil. Represent the pencil perpendicular to the plane as shown in figure 7.8b. Now NOA looks like it is a 90-degree angle. Okay. But NOB, it doesn't look like 90. By seeing that figure, you cannot say it is 90 until unless you say it is three-dimensional figure. Okay. So by seeing the figure only, you cannot decide that whether it's a perpendicular to OB or not. But actually it is perpendicular. You have seen it earlier. Okay. Isn't it?
Yeah.
So NOA looks like at 90 degree, but NOB doesn't look like a 90-degree angle. Is NOB 90? Yeah, NOB is 90 actually. What about NOC? NOC is also 90 and NOD is also 90. Okay. Because it's a normal to the plane and the lines are on the plane, so it's a perpendicular angle. Okay.
Yeah.
So that is the explanation for this question. Now, this figure 7.9 shows a cuboid. It's a cuboid. Dotted line represent lines that are hidden. So they are hidden lines. Hidden lines means if you place your book over here, so you cannot see back sides. Okay. Can you see the back sides if you place a book in front of you? You cannot see the surface which is back side of the book.
Yeah. Yeah.
Okay. So if you draw these lines, it cannot be seen.
Right.
So if we are drawing a line which cannot be seen in 3D figures, so it will be dotted. Okay. So dotted means they are not, you are not able to see that lines, but they are imaginary. You are imagining that line. Actually, they are there backside of the figure. Okay. Okay. So we can represent hidden lines like the dotted lines. Okay.
Yeah.
So you can see that if we join any of the three vertices, it has a total 8 vertices. It has A, B, C, D, E, F, G, H. It has total 8 vertices. So if we join any of the 3 vertices, we can draw a triangle. So how can we tell if the triangles are right angled? So is the triangle is right angled? If a triangle can be found between any 3 vertices of the cuboid, how can we tell if the triangles are right angled? We can use a geometry software template to visualize the cuboid in 3D. Go to www. Okay. So we can use this software. Okay, now I'll give you 2 scenarios. There are 2 methods to determine whether a triangle in a cuboid is a right angle triangle. Okay, what was that? They're asking. Okay. Okay, they are asking this one. They have made a triangle. So we have to check. The triangle is CG and E. This triangle is CG and E. Okay.
Yeah.
So you see that this GE is normal to the plane EFGH, isn't it?
Yeah.
So every line which is normal to this plane is normal to every line on this plane. Okay. So your GC, that is your GC. So GC, you see that it's a normal to EFGH. So if I draw any line on this plane, let us say, is it EG? EG, I have drawn a line on this plane EFGH. So it will also be normal to, it will also be perpendicular to GC.
Yes.
So this angle is 90 degree. Are you getting it?
Yes.
So that was the purpose of teaching this one. So that you can visualize So the next one, so there are two methods they have given you, but I don't think the two methods are required. Okay, you need to visualize it. Okay, now figure 7.11 shows a cuboid. It's a cuboid. Which lines are perpendicular to ABQP? Can you tell me which plane is this ABQP? You can visualize your room. Okay. So ABQP can be in front of you. Okay. That side is in front of you. And you can visualize which is normal to your plane.
So AP.
Which is normal.
ST.
As
No, normal.
this is the plane. Okay. It is A, B, C. Sorry, it cannot be visualized here. Okay. So is this AD perpendicular to this plane they're talking about? I will make it in different color. They're talking about this plane. So any line which is perpendicular to this plane, any line which is normal to this plane is perpendicular. Okay. So is this line normal? BC?
Yeah, BC is normal.
AD?
Yeah. And then PS and QR.
PS and QR. Okay.
Yeah.
You're getting it?
Yeah.
Okay. So like this, and we'll consider it for figure this question number 5. 7.12 shows a square based pyramid. That means in your base you have a square. Okay.
Yeah.
And you know the property of square?
Yeah.
What is the property of square?
So it has 4 equal sides.
4 equal sides and each angle is 90 degrees. Okay. So the base is a square based pyramid. Identify all the right angle triangle. You have to identify the right angled triangle.
So VWN.
VWN. Okay. VWN is a right angle triangle. Second one.
VNX.
VNX. Okay. Because VN is perpendicular.
Right.
Okay. VN is normal to this plane. So any triangle which has VN and the other two sides at this plane will be a right angle.
Yeah. So then VNZ and VNY.
VN?
Z.
VNZ. Okay.
VNY.
VNY. Okay. Any other?
So I think that's it.
Is this WXY?
Yes, WXY and ZWY.
ZWY. Okay, there are two triangles. Okay, any other?
No, sir.
Okay, very good. So this is just about the visualization of 3D figures. How you are visualizing it. That is the main motto to study this. Okay, now these are some practice questions. Okay, now it is the real testing of your visualization. Okay, so there are worked examples. I'll give you worked examples. You have to do it. Is it visible?
Yes, sir. Little.
Visible? Solution I'll not show you.
So can you move it a little bit aside?
This side?
Little bit to the left.
Okay.
Right. Right. Yeah. Okay.
You can place your video windows anywhere. Okay, I think it will be at the top side, but you can place it anywhere.
Oh, okay.
Do you want to have class tomorrow morning?
So I'm not sure if. So can you
Okay,
ask my mom?
yeah, you please ask your mom. Then
Yeah.
if it is feasible, then she has to drop me a message.
Okay.
Because Monday I'm moving somewhere. Monday,
Okay.
Tuesday I'll be busy.
Okay.
And we have to move ahead of your school,
Hmm.
not far from your school. Do all these two parts.
Okay.
Okay, did it?
So I got first part,
Okay, what is that?
30.66.
30.6. How it is 30.6? It is very simple. It is 3 by 5. That is 10 inverse 3 by 5. That is 31 degree. It is perpendicular over base. Okay. Isn't it? This angle.
Yes.
This angle.